faithful guide and friend, the earth. Look to her skies, so dear and so bright, that warm our hearts and bring us light. What a light! What a light, source of life and beauty. She takes care, protects you and me. When all over her dazzling mountain peaks, the majesty of ages speaks. So how have we returned her love? By poisoning the skies above, burning down her marvelous trees, and pouring waste into her seas. So let's understand and face our acts. We destroy our earth, that's a fact. Can't we bring back a smile on earth? Help her rebirth.
Ha, gotcha!
The origins of our climate.
We're trying to finish a properly documented article on the climate.
Yeah, but we still don't really get it. There have always been major climate variations throughout history,
And even ice ages.
and humanity survived.
What?
Huh?
No, there was no one.
Oh, yes, young man, there were.
So why are we making such a big deal about a little temperature difference of 2 or 3 degrees over a century?
But 2 or 3 degrees, that isn't a small difference. Do you want an example? 10,000 years ago, with only 1 degree more on average, the monsoon brought plenty of rain to the lush Sahara. Then, 5,000 years ago, the temperature dropped just that 1 degree. The rain stopped, and desertification began in those regions. Here's another example. At the end of the 17th century, there was in fact a short period of cooling. Well, of less than 1 degree. That was enough for the River Thames to freeze and for the painter Bruegel to start painting his snowy winter scenes in the Netherlands. But a mere 2 or 3 degrees more or less in our countries means much more in the far north. And you've seen the tragic consequences for our Inuit friends whose way of life is falling apart, and the wildlife in those places. And the state of the pack ice is getting even worse.
Yeah, I even saw a report on TV showing a giant iceberg 120 kilometers long breaking away from a glacier in the South Pole.
An iceberg 120 kilometers long? But that's 6 times the length of Manhattan Island.
It is, however, true. It was in Antarctica, towards the South Pole, where the temperature is minus 30 degrees, but can in fact reach to minus 70 degrees.
So everything froze.
Oh, it doesn't have to be so cold for things to freeze. And coming back to your first remark, a small change of 5 degrees to our current climate would be enough to cause an ice age.
Yeah. Oh, no.
Well, that's what happened 20,000 years ago. An ice cap covered Northern Europe, the United States, Canada, and Greenland. And the sea level dropped by 120 meters, equivalent to 2 floors of the Eiffel Tower.
120 meters? So where did the water go then? Into the air? Into the ground?
Well, yeah, it vanished. But it was swallowed up by glaciers. And so, you know, you could have actually walked from France to England.
There weren't any people back then, were there? Grimbo said.
But Maestro already told you there were. There were plenty of Cro-Magnons during the last ice age, you know.
And Neanderthals were around during the previous ice age 100,000 years before, and they didn't do too badly.
Well, it's not often said, but it's true. Our world's development was regularly punctuated by ice ages.
So many things have happened in history.
Well, for once, he's right. Can you tell us about the Earth's history, Maestro?
Right, well, as you already know, the planet Earth is 4.6 billion years old. That means 4, then 6, followed by a whole line of zeros. But there's not a lot of evidence left from that period. everything was churned up by the molten interior of the planet. Just imagine how hot it must have been. You know that these days, even now the Earth has cooled significantly. Its crust is only a 50 to 60 kilometer thickness of solid matter. That's the height of the stratosphere, or in relative terms, the thickness of an eggshell. The distance from Washington, D.C. to Baltimore. That's very little protection.
And what's under that layer, Maestro?
Well, there's rocks and then molten magma. But at 4,000 degrees, the layer splits and sometimes shatters when the pressure climbs too high. And that leads to earthquakes, volcanic eruptions, and lava flows. So here, the layer wasn't too solid yet. And the rocks seem to show that there was an ice age more than 2 billion years ago. Why? Any ideas? No? Then, for many millions of years, nothing. Periods of warming and cooling certainly followed. But first, 900 and then 700 million years ago, our Earth was just a huge ball of ice. The land froze, and then unfroze, repeatedly over time. But it's thought that somewhere there was always a section of unfrozen sea, where a little life could find refuge, maybe under a thin layer of ice where a ray of sunlight could find its way through. And these life forms would flourish at the slightest thawing. But let's stop for a moment at this point in our story with life about to bloom. Temperatures were now high, and there would soon be the first landscapes of extraordinarily rich, luxuriant plant life. In the water, our little microorganisms evolved into flagellates, volvox, and trilobites. Then the first organism whose fins turned into legs, which would first move on to dry land 360 million years ago. Over time, these newcomers turned into the Archaeopteryx, the first creature to take to the air like a bird. Still needs some work, I think. But this was already 160 million years BC, and a number of heavyweights had appeared. The peaceful Apatosaurus, 20 meters long and weighing in at 20 tons. The Diplodocus, the longest dinosaur at 30 meters with its swan's neck. And the champion of champions, the Brachiosaurus. It was only 24 meters long. A pretty thing, don't you think so? 12 meters high. That's 4 stories. But it weighed 50 tons in total. Imagine, the biggest land animal ever.
Hey, that thing wasn't the biggest. Nope. There are whales that weigh 150 tons, aren't there?
You're absolutely right, except that, to the best of my knowledge, whales aren't land animals. Oh yeah, there is one I have forgotten. The terrible Tyrannosaurus. Only 15 meters long, 6 meters high, but what power! And just look at its mouth, armed with 2 rows of 20-centimeter blades. Then there are others I've forgotten. The aggressive Elasmosaurus, 18 meters long, and seen here fighting with a huge crocodile. And the formidable Pteranodon, a flying reptile with an 8-meter wingspan. The Anatosaurus was normally a vegetarian, but sometimes varied its diet a little. But the Triceratops frowned on predators taking too close an interest in its offspring. Now, I know that some of you would like to become friends with these beautiful creatures, but you're out of luck. Humanity wouldn't appear on the scene for a long, long time. But some 65 million years ago, the dinosaurs died out. Global warming? A volcanic eruption? Who knows? We think it's very likely that a large meteorite hit the Earth, and the impact made it impossible for most species to survive. Now, I'd like to talk to you about another event that happened at almost the same time as the dinosaurs. Continental drift. Just listen to this. This is back in 1915.
And until 200 million years ago, all the world's continents were joined together to form just one, Pangaea. 30 million years later, and carried on tectonic plates, these continents began their slow drift towards the positions they have today.
Continents drifting around? Is this some kind of joke?
And at what speeds were they drifting, Mr. Wegener?
Oh, not fast. About 3 centimeters per year.
But that's just ridiculous. I mean, how wide is the Atlantic?
4,500 kilometers.
Right, so let's work that out then. 4,500 kilometers at 3 centimeters a year. How
Well,
much
do
is
the
that?
math. 170 million years is more than enough.
Right, you're kidding.
But it wasn't until 50 years ago that the scientific community accepted these facts. Yes, the ocean floors move, which explained why certain countries, such as Indonesia, are often hit by natural disasters. Since those subterranean movements could lead to volcanic eruptions and earthquakes, like the one in 2004, which devastated the region, and which also triggered the devastating tsunami with countless victims. And of course, all this affects the climate. Let's finish examining continental drift on this thin, solid layer that is propelled by the internal energy of the Earth. To better understand, take a look. That's the way our Earth was then. And then it moved, forming continents and seas. Here is what will become of the Atlantic. There, South America separates from Africa, which moves away. This will be Australia. And this block will drift south and become Antarctica. 30 million years ago, it was already quite a long way from America and Australia. Volcanic activity had subsided, and it was cold. Enveloped in layers of icy air, Antarctica began to acquire the envelope of ice 3 kilometers thick that still covers it today. Having split away from the rest, Africa began its journey north. Then, 12 million years ago, came the collision with the Arabian Peninsula. And 6 million years ago, our Mediterranean became a lake, which dried out for 1 million years. But I've already told you about all that. As you can see, when Africa attaches itself to Europe one day, there will be no Mediterranean at all. It vanishes. But don't worry, at the current rate, it won't happen for a while. Now, just 2 million years ago... 2 million years ago, South and North America met. And that ended the single ocean. No more exchange of water or equalization of temperatures. Oh, hey. Obviously, the fact that both land and sea had changed would have a considerable effect on ocean currents, continental relief, and, of course, climate. And at about the same time, that's about, well, 2 million years ago... Who should appear but humans? Well, not exactly true. The proconsul. Isn't he handsome? Right. Let's see what happens to him over time. Just watch. Proconsul, Australopithecus, Homo habilis, Pithecanthropus, Swanscombe man, Neanderthal, and 40 or 35,000 years ago, Cro-Magnon. This last time, it's our ancestor, modern man. During all this time, temperatures were pleasant and mild. But the pleasant temperatures changed over time, and it suddenly became very cold. Our friends were forced to travel south, following the herds that provided most of their food. The ice age that came 18 to 20,000 years ago was particularly severe. Unfortunately for our friends.
No, it was good for them. And that walking would toughen them up.
Some kind of walk. A 3-kilometer ice sheet crushed not just Europe, but the whole north of the planet. The Bering Straits. The temperature there was minus 30 degrees. The tribes from Asia used the ice as a bridge, crossing its frozen waters on foot. And they became the first Inuits and the first Native Americans. And in southern Europe, where the climate was milder, you could see mammoths. Seals and penguins took up residence in the Mediterranean. And musk oxen from Greenland wandered about on the Côte d'Azur.
Really? You could see them on the Crozet in Cannes?
Well, the Croisette wouldn't be around for a little while longer. Then, 2,000 years later, the temperature started to rise again.
Oh, well, that wasn't long then.
Vegetation and forests started to return. And with them came stags and boars. The boars were bred into pigs when the humans settled and became stock breeders and farmers. That was the Holocene period. It was an interglacial period that has in fact continued until this day. And that was the birth of civilization.
Well, I wanted to ask how many Cro-Magnons there were when they actually settled. I think there were about 35 or 40,000 just in Europe. Is that right, Maestro?
Oh, we don't know the exact number, but I don't think that's far from the truth.
That's not many for a continent.
But in a few short millennia, a period of time our friend said earlier goes by very quickly, the population of Earth would grow to about 1 million people. Or thereabouts.
Well, I must say, these amazing global ice ages and then the warmer periods you've told us about sounds very interesting. But you haven't told us what actually caused it all. It was hot, then cold, then hot, then cold again. I guess it didn't just happen like that without reason.
Oh, I don't know.
I think I have an answer. It's the axis of the Earth, which tilts in relation to the sun.
Not bad, not bad at all. But that's not the whole story. You all know that the Earth goes around the sun, yes? And as it does so, it tilts on its axis. However, its orbit isn't circular like this, it's an ellipsis like this. Of course, the further the Earth travels from the sun, the colder it gets, and this is what causes the ice ages. And when it gets closer, just for a short time, look at the curve. There's a thaw. Then the more tilted it is, the more the poles warm up, as they are closer to the sun. Obvious, isn't it?
How are you so sure, Maestro?
Thanks to the many years' work by a Serbian scientist, Milankovic. As usual, his theory was unpopular. All research carried out since has confirmed that. Our little planet's movements really are the metronome that regulates ice ages. What research did he do? Well, research into sea currents, ground strata, coral, seabed sediments, seashells, and water precipitated by storms. As always, human knowledge is only developed by human perseverance. The Marion Dufresne has just extracted a 50-meter core sample from the seabed, making it possible to read thousands of years of the Earth's history from the samples provided. And the equipment is getting better. 1980, Vostok at the South Pole, one of the coldest places on Earth, reaching minus 90 degrees. After 6 months of superhuman effort, a Soviet team managed to extract a 2,000-meter core sample from the deep ice. A few years later, another team raised a core sample of 3,000 meters. That's 800,000 years of history.
But tell us, Maestro, how do they manage to read these core samples?
Even the slightest climate change is recorded in the successive layers. They can detect the tiniest grain of sand carried from the distant Sahara by a storm. The slightest trace of volcano smoke that's blocked out the sun's heat and light. It all becomes obvious after analysis. There can be no mistake as to when these events happened.
Well, we've learned some really interesting things, Maestro, but nothing we can use to help our dear friends in the far north.
Nor why global warming is happening so much faster up there.
Yeah, much more quickly.
Well, you have been able to see that the icy surface on which their village is built, the permafrost, is melting away.
So why is it doing this,
Because of the rise in temperature caused by human activity and by
The
pollution.
greenhouse effect has put a huge spanner in the works.
Now, as you know, light surfaces reflect heat. But the dark ones, like the Earth, absorb it, so they heat up more. So a cycle starts in which the sun produces more and more heat.
And the glaciers melt and disappear.
But let's get back to climate. As you remember, it's been affected over time by a certain number of natural factors. Ice ages and warmer periods are due to the movement of the Earth around the sun. Ocean and sea currents move around the continents, which drift, causing earthquakes and volcanic eruptions. There is an artificial factor, the only one we can change. That's global warming due to human activity. But if you like, that can be a subject for another day.
See the mother who gave us birth, our faithful guide and friend, the earth. Look to her skies, so dear and so bright, that warm our hearts and bring us light. What a light, what a light, what a light.